So the addition theorem on probability. Okay. White screen is okay with you, or shall I change it to the dark background?
So the dark one is better, sir.
Okay. Okay. So addition theorem, it is we know from permutation combination, when do we add? Whenever there is uh, either or, either this event or that event, then we do that is when we add. So similarly here, addition theorem, first I'll explain with yeah, if for two events. So if A and B are two events in a sample space, then probability of A union B, this is your addition, is P of A plus P of B by P of A intersection B. So P of A union B is P of A plus P of B minus P of A intersection B. Okay. Now, how do we get this is, say, left hand side is probability of any event is the number of times that event occurs divided by the total number in the sample space, isn't it? Now from sets, if you remember, so this is the universal set. Okay, so universal set will be our sample space now, and this is set A, this is set B. Now A union B refers to this entire region. It is either A or B, and which means or both also. It is not saying only A. What's happening? It's not saying only A or only B. So this is this region. So from sets, inclusion, exclusion, we know that this is N of A, addition in sets, N of B minus N of A intersection B upon N of S. This is, say, the cardinal number of A includes all this region, plus cardinal number of B includes all this region within B. In the process, this A intersection B, the overlap overlap region has been counted twice. So therefore we have to count it once. So we eliminate it once. Okay. So this we get as n of a upon n of s plus n of b upon n of s minus n of a intersection b minus n of s. So we get this as we get this as probability of a plus probability of b minus probability of a intersection b. Okay. So this is the result. P of a union P of b is equal to P of a plus P of b minus P of a intersection b. For three events, for three events, A, B, and C, you have, we'll not prove this, but we'll just show it. Probability of A union B union C. Probability that either A or B or C occurs is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So first starts with single event, probability of the single events, all are positive. Next, probability of two events happening simultaneously, A and B. So AB, BC, CA with a negative sign plus probability of all three occurring simultaneously. So this is probability for three events. Okay, now how do you get this? Again, the same principle. I'll change colors, that might help. Uh, this is A. This is B. And this is C. Okay, so there are three events, A, B, and C. So for all of them to occur, A union B union C is the common region. All right, it includes only A, only B, only C, and it includes A and B, A and C, and all ABC, C and B, and then all ABC. So this includes the entire shaded portion, but taken once. So what happens is when you take P of A, N of A like this, N of A plus N of B plus N of C. In the process, what's happening is this particular region, the checks region here, this is counted twice. One time with A, other time with C. This region is counted twice. One time with C, other time with B. This region is counted twice. One time with A and one time with B. So, and this particular region is counted thrice. This particular region is counted thrice actually. So what do we do now? So this checks portion, the gray checks portion, has to be removed once. So that's why we remove A intersection B once, B intersection C once, C intersection A once. So in the process, this was counted twice and it is removed once. So it has been taken once, no problem. This region is counted twice and removed once. So it has been in effect counted once. Similarly, this region is counted twice and removed once. So it has been counted once effectively. That is not a problem. Come to the interior portion. This region was counted thrice earlier, along with A, along with B, along with C. Now when we are removing this, we have removed it thrice by including it in A intersection B, by including it in A intersection B, by including it in A intersection C, and by including it within B intersection C. So it has been removed thrice, but we have to count it once. That's why plus. So in countings, this particular result, not in probability, in counting, if it was n of n of n of n of, this particular principle is called as principle of inclusion and exclusion in a sequential manner. Now the same thing for n events. This is of course not there for your CBSE, but it is there for boards. I'm sorry, for the entrance exams if there are more. For n events, uh, probability of A1 union A2 union AN is, what will you get? Probability of all events taken individually. Next, with a negative sign, so inclusion, exclusion, with a negative sign of the intersection of taken two at a time. A1, A3, then A2, A3, then N minus 1. How many such? The first is there will be N terms. How many terms will this have? How many terms will this have? The first one will have N terms. How many terms will this have?
N minus 1.
No, no. N minus 1 if you take only A1, A2, A1, A3, A1, A4, so on up to A1, AN. But then after that you have A2, A3, A2, A4, A2, A5, A2, AN. Then you will have A3, A4, A3, A5, so on. How many terms? Tell me. NC2 terms. correct? From A1 to AN, select any two, right? In how many ways can you select any two? NC2, and that will pair. I want it within 1 minute. Okay, so NC2, got it? Clear?
Yes, yes, sir.
Next will be, see, we have excluded in the process, though that which is counted thrice will be excluded, so we have to add it. Then you will have P of A1 intersection A2 intersection A3 plus P of A1 intersection A2 intersection A4, so on, plus the last A n minus 2 intersection A n minus 1 intersection A n. How many terms? How many terms? N, C, 3
C3.
terms. Okay. So now depends on n. When n is 2, it is negative. When n is 3, it is positive. Last one will be minus 1 to the power of uh, n minus 1 P of A1 intersection A2 all at a time. The previous term will be minus 1 to the power n minus 1 times n terms. You will drop A1 once, A2 once in all the intersection. Okay, you will have n terms in the second last step. A1 to AN minus 1 plus A1 AN minus 2 intersection AN. You have dropped n minus 1. Here you dropped n. Like that, last you will get A2 to AN. You have dropped A1. So how many terms you will have? N terms. These are important because in some problems, tricky problems, they will use this. And last one will be only one term. Okay. So got it? Alternative minus plus, minus plus. First one starts with plus, then minus, plus, minus, plus, minus, plus. So that is what this equation says. So this is a very short, in mathematics, something that you need to appreciate about mathematics is very complicated, long equations. You can write it very short using notations. So look at this one. So P of A1 union A2 union A3 so on up to AN is sigma I equal to 1 to n P of AI. This covers the first minus sigma I less than j P of AI intersection AJ. It will cover all the cases. All right, NC 2 cases. Then sigma I less than j less than k P of AI intersection AJ intersection AK. NC3 terms you will get. Similarly, going on, minus 1 to the power n minus 1. This one. All the entire. So this is the generalized result on addition theorem. This is now if the events are mutually exclusive. What are mutually exclusive events? Mutually exclusive events means if one event occurs, the other cannot occur. Other cannot occur. Like a coin is tossed. You can get either a head or a tail. So getting a head is an getting a head and getting a tail. They are exclusive events. Mutually exclusive events. If the events are mutually exclusive, for mutually exclusive events, um, what happens? A intersection B will be equal to phi. So P of A union B will be P of A plus P of B minus P of phi, which will be 0. So for mutually exclusive events, addition theorem just simply boils down to this. So these are mutually exclusive events. There will be no overlap. So probability will be addition only. Now, if you have n events, if you have 3 events, no two, any two taken in pairs are mutually exclusive, which means there's no intersection at all. So if A, B, C are mutually exclusive events, then this is the result. And similarly for n cases, P of A1 union A2 union AN will be P of A1 plus P of A2 plus P of AN. Okay. So, and how will be the Venn diagram? For all mutually exclusive events, each one will be a circle of its own. Without overlap. Okay, so on. So you get A1, A2, A3, so on up to AN. These are mutually exclusive events. Let's do some problems before we go to more. There are more results on this. Let me share. These are very long problems too. Do you have your textbooks with you? A few problems from textbooks I'll do, and then Do you have textbooks with you? Kedar and Harshita? CBSE.
Yes, I have it, sir.
Okay. So it'll take time for me to dictate problems. That's why I want to um, just tell you the problems. First, I'll do the um, numerical one simply. Check. Then I will do the other ones. 12 and 13.
So, which
12.
exercise will you be taking it from?
This is exercise number 16.3.
Yes, sir, 16.3.
Okay, 12 and 13 are direct. You can just apply the formula and see. 14 is a very simple one. Fourteen is a simple one. It says P of A is 3.5 and P of B is 1.5. Find A or B. Find probability of A or B. We also say probability of at least one of A and B occurring. Okay. Find A or B if A and B are mutually exclusive. If A and B are mutually exclusive, this is a straightforward problem. What's the answer? If they are mutually exclusive, P of A union B is nothing but P of A plus P of B. So this is 3 by 5 plus 1 by 5 is equal to 4 upon 5. This is the probability. Now let us do this one. 15th. P of E, event E is 1 upon 4. P of F is 1 upon 2. And P of E and F, that is E intersection F, is 1 upon 8. Find P of E or F, that is P of E union F, and P of not E and not F. Okay, the first part is simple. Answer?
So 5 by 8.
Yeah, this is P of E plus P of F minus P of E intersection F. So 1 upon 4 plus 1 upon 2 minus 1 upon 8. So taking 8 as the least common multiple, 2 plus 4 minus 1. So 5 upon 8. Now next is probability of not E intersection not F. Let us see that how this will be. This is E and this is F. Now not E, not E. So this is E. Okay, not E means all this region other than E. All right. Other than E, all the region is not E, E bar. And not F means other than F, this is F. So other than F, all this region. Now he says intersection of not E, not F. This is, if you observe, intersection means both red and yellow lines have to be present. Now red and yellow lines are present only for region. I'll mark like this. Region outside of this shaded portion. Understand? Because here it is only not E. Here it is not F, but not both, na? So not E, not F means this region which is outside, which is same as 1 minus P of E union F. This is an important result. This is an important result in probability. Probability of E intersection F is 1 minus P of E union F. Why 1? Because it is actually n of S by n of S. That's why you'll get 1 minus. Probability of this entire region is 1. Okay. So therefore, P of not E intersection not F is 1 minus 5 upon 8, which is 3 upon 8. All right. Okay, next question, 16th. Is it clear? Shall I proceed further?
Yes, sir.
Next question is a more logical question. I have to see. So E and F are events such that P of not E or not F. Okay. Now it is or. P of not E or not F is equal to 0.25. State whether E and F are mutually exclusive. Now let us see this. Now P of not E union not F will be 1 minus P of E intersection F. Same, let us go back to the previous one. Now the previous one is here. See, previous case it was intersection, here it is union. Union means either of this or that. So either not E is these yellow lines, either not E or not F. Not F is this red line region. So either or means either one of them exists or both of them exist. So it includes all the shaded region. So only one particular region is not shaded, and that is this intersection. Okay. So when you say not E union not F is 1 minus. So other than this unshaded region, all has to be taken. So you get 1 minus P of E intersection F. So this 1 minus P intersection F is 0.25. That means this entire shaded portion is 0.25, which implies P of E intersection F will be 1 minus 0.25, which is 0.75. Now there are inequalities I've not taught, but we'll soon do that. Say this, P of A plus P of B will be greater than P of A union B. Greater than or equal to. Equal to will hold when equal to will hold. Tell me when.
When the events are mutually exclusive.
Very good. When the event are mutually exclusive, they both will be equal. Otherwise, this will be greater than this. And so, and P of A intersection B will be much lesser than P of A union B. Okay. So, actually, the whole thing is like this. P of A intersection B will be less than or equal to either P of A or P of B, which is less than or equal to P of A union B, which is less than or equal to P of A plus P of B. This is the entire inequality. The intersection has to include both A and B. So it will be less than A or less than B. Okay. Then each individual will be less than A intersection A union B, and the union will be less than the sum of them. So this is the inequality that you can remember. And it is not the common sense logic. So let us go by this. Now P of A union B is P of A plus P of B minus P of A intersection B. So now this is P of A plus P of B minus 0.75. Oh, so I have to use the events E and F. Okay. Now what is the maximum possible value of E intersection F? Maximum possible value of E intersection F. Sorry, E union F. P of E union F. E union F, the maximum possibility is when E and F cover the entire set, universal set. Events E and F cover the entire sample space. All right. In that case, this will be less than or equal to 1, which is P of E plus P of F is less than or equal to less than or equal to 1, which is P of E plus P of F is less than or equal to 1.75. Understood? And now, all right, and P of A or P of B has to be greater than P of E is greater than P of E intersection F. So similarly, P of F will also be greater than P of E intersection F. 0.75, 0.75. All right. So P of E plus P of F will be greater than or equal to 0.75 plus 0.75, 1.5. So what do you conclude now? Tell me the answer now. P of E plus P of F lies between 1.75 and 1.5 and 1.75. Are these mutually exclusive? Answer. Did you understand what I did? I found the region, the interval in which it lies. I have used two. One is P of E union F has to be less than 1. Okay, I calculated that. This is first part. Second part, I used that P of E has to be greater than P of E intersection F. So P of E intersection F itself is 0.75. So P of E at least must be 0.75. Similarly, P of F must be at least 0.75. So their sum must be at least 1.5. Now, if E and F were mutually exclusive, if E and F were mutually exclusive, then P of E union F will be equal to P of E plus P of F, and this cannot exceed 1. All right. So comparing statements A and B, we conclude what? E and F are not mutually exclusive. Got it? See, I had this picture mentally. All right, I didn't have to do all these steps. The picture that I had mentally was this: A intersection B. Okay, sorry, A union B. Mutually exclusive means there is no overlap. So the sum of them has to be less than the total sample space. That means the probability of A plus probability of B must be less than or equal to 1. So the minute we got this, that E intersection, see, P of E plus P of F is less than 1.75. So that itself showed that it is not possible. Uh, but then it is possible that they can still be less than 1. So we had to eliminate that possibility. So what did we do? We checked the individual probabilities. Individual probabilities will be greater than 0.75. So it is 1.5. So it is greater than 1.5. And the sum of the for if they were mutually exclusive, the sum of their probabilities had to be less than 1. So they are not mutually exclusive events. Okay.
So I'm not getting this. It should be less than one for both the cases, right?
Which are the cases? No, no,
Like
no. This
even if
is
it is
mm,
even if it is mutually exclusive or not, it does not matter, right? It should be less than one only.
no. The sum can be greater than 1. Na? Probability of E, let us say, is 0.8, and probability of F is say 0.9. The sum can be greater than 1.
So it will be greater than one in which case?
No, the sum is greater than 1. If it is mutually exclusive, it cannot be, probabilities cannot be 0.8, 0.9. It can be 0.8 and 0.1. Then it can be mutually exclusive. Shall I take an example?
Yes, sir. Please.
Okay. Let's take an example of tossing 2 coins. E is the event of getting at least one tail. What will be the event? Tail, head, tail, tail. Oh, and head tail. Yeah, correct. First time it is tail, and second coin, first coin tail, second coin head, second coin, first coin head, second coin tail, both coins tails. F is the event of getting at least one head. So tail head, head tail, head head. Now E union F. E union F is the total sample space. All possibilities. Tail tail, tail tail, heads tail, tail heads, heads heads. Okay. What is E intersection F? E intersection F. What are the intersecting terms? TH, HT. All right. Now they're not mutually exclusive, right? Now let us check their probabilities. Probability of E is 3 by 4, 0.75. Probability of F is again 3 by 4, 0.75. Probability of E intersection, because see, probability is 0.75, probability of F is 0.75, probability of E plus probability of F is 1.5, and probability of E intersection F is half. Understood? So this is an example in which individual probabilities are of two events. They are such that the sum of them is greater than 1. As long as sum of them is greater than 1, it cannot be mutually exclusive. P of, what is P of E union F? 1, right? So P of E plus P of F minus P of E intersection F is equal to 1. And if this is not 0, If this is not 0, then P of E plus P of F will be greater than 1. So as whenever the sum of the probabilities of two events is greater than 1, they cannot be mutually exclusive. If they are mutually exclusive, then this intersection term has to be 0. Understand?
Yes, sir.
Clear? Kedar, clear for you?
Yes, sir. Clear, sir.
Last problem for today. This is problem number 18. Last ninth of a school, 40% students study maths, 30% biology, 10 study both maths and biology. And this is easy. This is just two events. Anyway, I'll do exercise problem number 18. 40% students study maths. Okay, so in a total school, 40% students study maths. So n of m is, let's say, 100 student. So 40% of the students. All right. Uh, Within 100 students, it means 40. Let's say total 100. Then n of b is 30. N of m intersection b is 10. If a student is selected at random, find the probability that he will be studying mathematics or biology. What he is asked is, so probability of m is 40%, which is 0.4. Probability of biology, a student studying biology, is 30%. It is 0.3. This can be mutually exclusive, but because 0.4 plus 0.3 is 0.7, this can be mutually exclusive, but it has already been given that the intersection is not 0. Intersection is 0.1. So probability of M union B. So this is probability of M plus probability of B minus probability of M intersection B. So it is 0.4 plus 0.3 minus 0.1, which is 0.6. So 60% of the students study either maths or biology. Okay, clear?
Yes, sir.
Similarly, example 19th, I think we are through. You can do 19 and 20. And 19, there are two different examinations, and the entrance test is graded on based on two examinations. Probability of a randomly student passing the first examination is 0.8, and probability of passing the second examination is 0.7. Probability of passing at least one of them is 0.9, 0.95. So what is the probability of passing both? So exam 1, probability of passing exam 1 is 0.8. Probability of passing exam 2 is 0.7. Probability of passing either of them is 0.95. Then what is probability of passing both? There's a question. Just by addition formula, probability of E1 plus probability of E2 minus probability of E1 union E2. Because in addition formula, this term is on the left hand side, this term is in the right hand side. You can exchange it. So you get 0.8 plus 0.7 minus 0.95. So you get 0.16, so 0.65. 0.65 is the answer. Okay, you can do the rest of the entire exercise. You can finish now. There are miscellaneous examples. In the next class, we'll do miscellaneous examples and then we can stop on this. All right, shall we stop?